I now welcome Dr. Murlidhar Tambe to say a few words.
Chief guest and Dean, BJ Medical College, Dr. Vinayak Kale sir, Dr. Neena Nagdev, President of Indian Association of Medical Microbiology, Maharashtra chapter, Dr. Anuradha Deshmukh, Secretary, IIMM, Dr. Rajendra Surpan, he is the Treasurer of IIMM, Maharashtra, Dr. Rajesh Karyakarte, Professor Head of Microbiology here in BJ Medical College, as well as the Organizing Secretary, Dr. Smita Deshpande, Professor of Microbiology in BJ, as well as the Joint Organizing Secretary of this conference, and many dignitaries among the audience, ex-Dean of BJ Medical College, Dr. Bharadwaj Madam, Professor Justin, former Dean of Miraj Medical College, Dr. Jagirdar sir, former Director of Hafkin, Dr. Chaudhary sir, Dr. Anup Anvikar, Director, NIB, New Delhi, Dr. Anurag Agarwal, Director, IGIB, and many others. Dear friends, I am very happy to be present in this conference, which is the first major conference which is held in the physical mode after this COVID. And we could not imagine, say just 1 year back, whether this would have been possible. 2 years back, as you all know, when this whole pandemic of COVID-19 started, how difficult were the things, how difficult were the times that we passed through. We did not even know that whether we would be, how many of us would be present in the next conference like this. The challenge was huge because this was the only major government medical college hospital in this region, and there are no other major hospitals in this Pune region for the Western Maharashtra as such. Even the health services from the Pune Municipal Corporation were very rudimentary. And the government was looking forward to us to provide this, to fill this gap. And we were the major providers of that. So at that time, starting with this, RT-PCR and genome sequencing, it was such a difficult time. Lockdown was there. I remember, these people working till 10 o'clock, 11 o'clock, 12 o'clock. Even they had not taken even a single day off for months together. We are not like, any defense personnel. We are not trained to do that for this work in a crisis mode for months together. And making available the material, opening the shutters of the shops in the middle of the night. And within 1 week, let me tell you, within 1 week, we were able to provide the RT-PCR lab here. Otherwise, RT-PCR was not there earlier, as far as the COVID is concerned. So we took up that challenge. Even the genome sequencing was thought of, it was only in very few centers in the whole of India. And a premier institute, central institute, which is very close by, they refused to accept the sample, saying that they were busy with other major things. And the number of samples that were coming up, and the government of Maharashtra wanted data, a Maharashtra specific data, and who could provide that? So it was the BJ Medical College who took up the challenge, and I'm very happy to say that Dr. Rajesh Karyakarte and his team, they took up the challenge and provided, I believe, more than 5.5 or 6 lakh RT-PCR tests have been done, and genome sequencing more than 34,000 he has coordinated for the Maharashtra, and about 5,000-6,000 have been done here only in this laboratory. So that is the contribution from this institute. So as yesterday also I was saying that, see, such a thing is possible in an institute like this, where we have limited resources, where we have limited funding. Within that we could provide this. That is the belief in among ourselves. Now this, I must say that the theme of this conference, the molecular epidemiology, is very, very aptly chosen. Looking at the present times, looking at the present situation. COVID-19 pandemic has highlighted the importance of this genomic sequencing to support public health decision making. It was the rapid sharing of the first viral genome sequences of SARS-CoV-2 which showed that this virus is a member of the species severe acute respiratory syndrome related coronavirus and is closely related to SARS-CoV and a diverse group of SARS-like coronaviruses identified in the bats. And later on, even the WHO took up that to trace the origin of this pandemic. It was also the timely sharing of the first viral genome sequences which enabled the establishment of diagnostic tools, and ultimately that led to the development of the vaccines. Since then, you know, millions of whole genome sequences have been generated and shared through that GSAID platform or many others. This genomic resource also allowed detection of mutations that might affect virulence, pathogenesis, host range, and immune escape, as well as the effectiveness of SARS-CoV diagnostics and therapeutics. It's not only used for this SARS-CoV pandemic, but this virus genome sequencing has been increasingly used in recent years for outbreak research, as seen in the recent Ebola virus outbreak in Africa. Molecular epidemiology, it allows for an understanding of the molecular outcomes and implications of diet, lifestyle, and environmental exposure, particularly how these choices and exposures, they result in acquired genetic mutations and how these mutations are distributed throughout selected populations through the use of biomarkers and genetic information. Molecular epidemiological studies are able to provide additional understanding of previously identified risk factors and disease mechanisms. We can also use this molecular epidemiology for measuring the geographical and temporal distribution of disease risk factors, which we did for SARS-CoV. Also, we can use it for characterizing the evolution of pathogens and classifying new pathogen species. Evidence indicates that disease evolution, it represents inherently heterogeneous process differing from person to person. Conceptually, each individual has a unique disease process different from any other individual, considering the uniqueness of the exposomes and its unique influence on molecular pathologic process in each individual. Studies have become increasingly common in the field of cancer to study the relationship between an exposure and molecular pathologic signature of the disease. But I must say that there is paucity of interdisciplinary experts and training programs in the use of molecular pathology and epidemiology. And it is such activities like this conference, the workshop that we had yesterday, will go a long way in addressing these issues. And I must compliment the organizers of this workshop and this conference. Currently, thousands of non-synonymous mutations have been observed. With ongoing transmission, such mutations can be replicated in subsequent rounds of infection, evolving into a unique fingerprint. When sufficient diversity is observed, the fingerprints can be used for epidemiological analysis at different levels of resolution. For instance, to link the cases to a cluster, to track the origins of outbreaks, to understand the seeding of pandemic waves, and to monitor the effects of control measures. And lastly, I have a word of caution here. Although the number of genomes is unprecedented, the whole thing about this COVID-19 is unprecedented. The coverage is still heavily biased towards regions and countries with specialized genomic facilities, programs, and research projects. There are several challenges that the field of molecular epidemiology is facing today, particularly selecting and incorporating data in an unbiased manner. Samples of convenience, both of the target population and genetic information, small sample sizes, inappropriate statistical methods, poor quality control, and poor definition and target populations will be challenges that we need to keep in our mind. I wish this conference, I am very happy with the response that this Maharashtra Association, Maharashtra chapter of this Indian Association of Medical Microbiologists has received. So many people have come and attending this conference in physical mode. I wish this conference a grand success. Thank you.
Thank you, sir. Thank you for briefing about starting of sequencing laboratory in microbiology department. We are extremely proud of having sequencing lab in BJGMC Pune. Your support was enormous for the same. Thank you. Now I request Dr. Vinayak Kale to express his thoughts.
Morning to afternoon. So good afternoon to all the delegates coming from corner of the Maharashtra. On the dais, ex-dean and professor head, Department of Community Medicine, Dr. Tambe sir, President of Maharashtra chapter of IAMM, Dr. Nagdev madam, then Dr. Anuradha Deshmukh madam, Dr. Rajendra Surpam, Chief of this organizing committee for this Maharashtra chapter of the state conference, and Professor Head of Microbiology and Vice Dean for Undergraduate Education, BJ Government Medical College and Sassoon Hospital, Pune, Dr. Rajesh Karyakarte sir, Professor Smita Deshpande madam, all the dignitaries of the dais, very senior microbiologist sitting in front row. I can name, the first name I can take, my professor and head, Department of Microbiology at Government Medical College, Solapur, ex-professor head, and then he was later on he became a dean of the medical college, Solapur, and medical college, Government Medical College, Miraj, Dr. Jagirdar sir. He was dean to me. He was teacher, professor to me when I was a student at VM Medical, Government Medical College, Solapur. I can again take the name of Dr. Chaudhary sir. Chaudhary sir was a professor and head at Grant Government Medical College and Sir JJ Group of Hospitals, Mumbai, where I have worked for nearly 22 years. He was ex-director of the Hopkins Institute, Mumbai. So it is my pleasure to welcome you, and I am proud of my department, Department of Microbiology, who is the host for this today's conference, where I am the head of the institute. This Department of Microbiology is a very important department in our college. Here, first of all, I congratulate Dr. Rajesh Karyakarte sir and his team of faculty who have successfully organized the Maharashtra Micro Conference 2022. This conference is going for 2 days. This conference is full of activities. There are orations, there are speeches, oral papers, poster presentations, and even it's been organized the postgraduate quiz. And all the topics of discussion moves around one important theme, and that theme is the molecular epidemiology. This very needful theme, what I think. And just now the community medicine professor and vice dean, Dr. Tambe sir, has explained more about this molecular epidemiology theme. This conference are having very interesting topics for deliberations. I can name the few topics. One is the variants and vaccines, SARS-CoV-2, genomic surveillance in India, genome sequencing, genomic and informatics. These are the very important topics. Will be enlightened by a very great, renowned and authority speakers who has been here attending this conference. I can name the few speakers. Just now you have heard in the morning, Dr. Neena Nagdev, her presidential speech, Dr. Uma Tendulkar madam, Professor Justin O'Grady, Dr. Anurag Agarwal, Dr. Sridhar Shivsubbu, Dr. Vinod Sakaria, and Dr. Anup Anvikar, who is the director of NIP, New Delhi. I think who is sitting in the back. Anup Anvikar is sitting in the back of these benches. Now, my special thanks to, and I can mention specially Dr. Rajesh Karyakarte, Professor Head, Department of Microbiology, and also his Vice Dean, Undergraduate Medical Education, for taking his Department of Microbiology, BJ Government Medical College, to the Himalayan heights. I'm very proud to tell this gathering that the variant Kappa and Delta in this COVID pandemic were identified by Dr. Rajesh Karyakarte and his team. And I am very thankful that this department is been progressing under the able guidance of Karyakarte sir, Dr. Smita Deshpande madam, Dr. Suvarna Joshi madam, and I can take a special name, though he is a junior one, Dr. Sunil Bhamre. Sunil Bhamre is a young microbiologist. He is very helpful. He is very helpful to the administration of the college and hospital. So I specially mention his name. Yesterday, we have a pre-conference workshop, which was attended by number of young microbiologists, and I am sure that those who have attended yesterday's pre-conference workshop, they have benefited most, and that whatever information or knowledge they have got yesterday, they will utilize in day-to-day practice. At last, because this is a Maharashtra state conference, so I will end with Marathi. I have started with English, but I will end in Marathi. So, at last, I want to comment on the subject microbiology, because this is a conference of microbiology. The microbiology is a very difficult subject. As an undergraduate, I can comment, this microbiology is a very difficult subject. So why I want to say it is difficult? So I will talk in Marathi. Microbiology जो subject आहे हा मायक्रोस्कोप पासून सुरुवात होते. म्हणजे जोपर्यंत आपण मायक्रोस्कोपमध्ये पाहत नाही तोपर्यंत आपल्याला मायक्रोबायोलॉजी सब्जेक्ट काय आहे हे समजत नाही. आता मायक्रोस्कोपमध्ये पाहण्यासाठी आपल्याला काही सराव करावा लागतो. म्हणजे पहिल्यांदा सर आपल्याला 2 डोळ्यांनी पाहायची सवय असते. मायक्रोबायोलॉजीमध्ये आपल्याला एका डोळ्याने पाहावं लागतं. म्हणजे पहिल्यांदा हा डावा डोळा बंद करायची सवय आपल्याला करून घ्यावी लागते. हे पहिला सराव आहे की जो आपण 2 डोळ्याने पाहायला गेलो तर ते मायक्रोस्कोपमध्ये काही स्लाईड काही दिसून येत नाही. म्हणजे पहिल्यांदा डावा डोळा बंद करण्याची प्रॅक्टिस करावी लागते. नंतर दुसरा जो उजवा डोळा आहे जो आपण त्या लेन्सवरती ठेवतो, तर तो कारण आपल्याला 2 डोळ्यांनी बघायची सवय असल्यामुळं ते आपल्याला एका डोळ्याने पाहायचं आहे. म्हणजे दुसरी जी आपल्याला प्रॅक्टिस करायची आहे ती उजव्या डोळ्याची प्रॅक्टिस करायची आहे, की आतमध्ये जे काय आहे ते पाहायचं आहे. आणि एकदा डावा डोळा बंद करायची प्रॅक्टिस संपल्यानंतर उजव्या डोळ्यानं पाहायचे जो सराव आहे तो संपल्यानंतर मग आपल्याला काहीतरी खाली जे काही स्लाईड ठेवलेली आहे ती दिसायला सुरुवात होते आणि मग काय आहे काय आपल्याला समजत नाही. म्हणजे परीक्षा येईपर्यंत मायक्रोबायोलॉजी हा विषय मध्ये आपण पास झालो युनिव्हर्सिटी एक्झाममध्ये, हे होईपर्यंत आपल्याला मायक्रोबायोलॉजी काही समजत नाही, असं म्हणजे माझं मत आहे. ते आता अलीकडं मला सरांनी सांगितलं की आता ते सिम्पल मायक्रोस्कोप आहेत ते आता बंद झालेले आहेत. त्याच्यानंतर दुसरी सेकंड जी फेज आहे, ग्रेड जी आहे, पेंटाहेड मायक्रोस्कोप, म्हणजे एका वेळी आपल्याला एकालाच पाहता येत होतं. आता सर म्हणाले की आता आपल्याला एका वेळी 5 लोकांना पाहता येतं आणि ते 5 लोक एकमेकांमध्ये डिस्कस करू शकतात. आणि त्याच्या पुढचंही त्यांनी मला आता प्रोग्रेस सांगितली टेक्निकली, की आता आपण जे काही स्लाईड आहे ती केवळ आपण पाहतो असं नाही, तर ती स्लाईड आता प्रोजेक्टही करता येते आपल्याला. म्हणजे स्क्रीनवरती जी स्लाईड आपण खाली एका डोळ्याने पाहत होतो ती स्लाईड आपल्याला आता प्रोजेक्ट करता येते. आणि प्रोजेक्शन जे आहे त्याच्यावरती आपल्याला जे काही टिश्यू असेल, जी काही पॅथॉलॉजी असेल ते आपल्याला सगळ्यांना सांगता येते. म्हणजे इतका हा जो अवघड विषय होता काही 20, 25, 30 वर्षापूर्वी, तो टेक्नॉलॉजिकली आता फार सोपा झालेला आहे. आणि त्याच्यामुळं आता मला नाही वाटत की आता जे विद्यार्थी आपले असतील, अंडर ग्रॅज्युएट असतील किंवा पोस्ट ग्रॅज्युएट असतील, त्यांना हा विषय तितकासा आता अवघड वाटत असेल. आय होप and I am sure that this annual state conference will be a great success and you will be benefited from the deliberations undertaken in this state conference. My best wishes to this conference, my best wishes to the organizers of this conference, and again as the head of the institute, Dean of BJ Government Medical College and Sassoon Hospital, I welcome you all for this 2 days conference. As I am a dean of this college and I am the host of this conference. Thank you very much. Thank you very much.
Dhanyawad sir. Thank you for your kind words and encouraging us throughout. I now call Dr. Suvarna Joshi, Associate Professor, Department of Microbiology, to propose vote of thanks.
I am thankful to our beloved Dean, Dr. Vinayak Kale, for his constant support and encouragement. I am thankful to our Chief Guest of Honor, Dr. Murlidhar Tambe sir, Vice Dean and Professor and Head Department of Community Medicine, for his continuous encouragement. We are thankful to the President, Secretary and Treasurer of IIMM Maharashtra chapter for accepting our request to organize this conference in 2019, which we are holding it in 2022, and gracing this occasion. Thank you all.
Thank you, Dr. Suvarna. Now I request all the dignitaries to step down and be seated in the auditorium because we are starting the next session, which is keynote address by Dr. Rajesh Karyakarte. To deliver keynote address.
Good afternoon to all of you. I started with telling you about why we had a particular theme for the conference, and that theme was molecular epidemiology. The theme is based on what I'm going to talk right now: genomics, variants, and molecular epidemiology of infectious diseases. So I'll just make a very brief presentation because we are running out of time. We are a bit late right now. So let me start with it. Just have a look at the definitions of genomics. Now here, it was a very new field for us, and we really started from these definitions. We did not know many of the definitions then when we started the whole thing. And for the first time, we came to know that, well, this, it's counted in bases, and yes, something KB there. So KB stands for kilo bases rather than kilobytes. And those were the new things for us. But yeah, it was 30 KB worth of the genome, which we studied a lot. So genomics is an interdisciplinary field of biology focusing on structure, function, evolution, mapping, and editing of genomes. A genome is an organism's complete set of DNA, RNA in the case of RNA viruses, including all its genes as well as its hierarchical three-dimensional structural configuration. Then in context with the theme of the conference, we will focus on viral genomics, and that to SARS-CoV-2. So all the subsequent lectures would be focusing on the genomics of SARS-CoV-2 and how it is important in molecular epidemiology. Then as just a passing reference, I will tell you that molecular epidemiology is also useful in monkeypox, Zika, and tuberculosis. Now this and tuberculosis is very important for India, simply because our Prime Minister wants TB out of India by 2022. So this particular field is very important for us, and for that particular reason, giving the due importance which tuberculosis has in India, the first lecture would be by Justin, and he's going to talk on the genomics based testing which he is developing right now in UK at Nanopore Technologies. So that is what I wanted to bring in, that well, tuberculosis is important for India, molecular genomics is important for tuberculosis. The Prime Minister wants it out of India by 2025, and we have a tool for that. And the best in the world, the manufacturer of the tool, the creator of the tool, is there in the conference. That is the importance of this particular conference, and that's why I wanted to emphasize on you. So something like that, I think would be very useful for all of us. Then variants. It was told right now by our dean, and I'm very glad that he acknowledged it, because as Anurag knows it, credit is seldomly given, and is mostly other people try to take the credit for things which they did not do, starting with the mutations of kappa and delta. And we have had a long journey from that particular point, which is now culminating with BA.2.75, where we had a role to play. Particularly the designation of 22D. That was done by Nextclade. And if everybody has a look at his certificate, we have made it a point to place in the background as the watermark that particular photo shot, which was tweeted by Nextclade, when they said that they are designating BA.2.75 as 22D, and where we had our sequences in it. So it's the screenshot of that particular Twitter post, which is in the background of each and every certificate which we have. So I think that is the thing which I wanted to emphasize on that particular note. Yeah, so variants are important, and tracing of variants has become very important with SARS-CoV-2, because what we have seen up till now is whenever a new variant comes in, which is more fitter, it leads to a new wave. And so to catch hold of a new wave, we need to have a very close watch on the variants. More importantly, the GZ which I have given there, Nexttrain and Pango, these are pioneering websites which are there, which are doing stellar work in the field of genomics right now. This is something important. So when we say Wuhan strain, please don't say Wuhan strain. WHO says that it should be called as the index virus. And then we have named the viruses as, there's a very important person sitting here who names the viruses for WHO. He's there with us. Dr. Anurag Agrawal is there. Yeah. So just to give an example of the whole confusing thing, most of the people don't understand what is going on in this variant field. Just to give you an idea that when we call it as delta, I'll show that one. When we call it as delta, it is this long numeral that is there. GZ says something else. And next one says in a very simple way, 21A, 21I, 21J, and so on. So these are the names of the variants, which not only we, but all the lay public in India now know. That delta hai kya, or kya Omicron nikla kya, and all those things go on. Even BA.2.38 nikla kya, abhi BA75 ka chal raha hai abhi. Otherwise, that like that advertisement na, kya chal raha hai, India mein kya chal raha hai? The fog chal raha hai. तो अभी इंडिया में क्या चल रहा है? तो अभी 75 चल रहा है. So that is how I think it goes in India right now. Yeah, molecular epidemiology. This is, it's unprecedented. Lab like ours, which had never dreamt of sequencing, could do sequencing. So it's genomic sequencing has been as a mammoth scale all over the world. Justin was talking, we were discussing yesterday, Justin and I. UK did the most. And his lab did a lakh of sequences. So, so I'm saying 1 lakh because there are people there who have done more than that there, sitting there, IGIB. They have done more than that. So I hope, no, I think, no, it was cut short, yeah. When Anurag left. Yes. So, yes. So I think molecular epidemiology is important for these things. We can study the origin of the pandemic, which politically we have not been able to trace up till now. So how did it all start? From a lab or from somewhere else. Then spread of outbreak investigations in hospital, nursing homes, schools, mink farms, all these things. Particularly important was very early in the pandemic, we came to know that SARS-CoV-2 spreads through airborne transmission. And that was in a choir which they did. But somehow that particular fact was not emphasized more. What was emphasized was those washing of hand and all those things. So I think we had the evidence, but we didn't use it much. Now with this, the important thing I wanted to tell that I have already told you about kappa and delta and also 75. BA.2.75, we red flagged it in June itself, I think that time. And right now what we know is that it's going to replace almost everything all around the world. All right, so with this background, and because we had done, I'm going to now have a talk on what we did, only a small talk, I won't take much of your time. Because we identified the kappa and the delta variants mutations long time back, the government of Maharashtra came out with a very innovative type of sequencing activity. Now let the whole, please, I want you to listen to it very carefully, simply because what a government can do is a very important thing. Kerala government had already done sequencing on its own, which was in addition to INSACOG, the central sequencing activity. And IGIB was involved in that particular sequencing. And it was a fantastic activity which was going on. Now what had happened at our place was we did find kappa and delta, but we were not finding all the details. We, in the sense, Maharashtra government was not finding it. And therefore, looking at what happened in Kerala, Maharashtra government decided that we will do sequencing on our own in addition to what is being done with INSACOG. So what government came up with was something like this. Government came up with a GR where it made a MOU with government between government of Maharashtra. It would be the director who would do it from Maharashtra side, and from IGIB it would be Anurag Agrawal who would be signing that particular MOU. So this was a very important decision, a financial decision, a big financial decision, which was taken by government of Maharashtra. And I want everybody, because all of you can read Marathi there, and that GR specifically mentions that there were mutations which were found in BJ Medical College, and that has made to doing this particular activity of genome sequencing in collaboration with IGIB. So this activity was the most important sequencing activity which was done in Maharashtra along with IGIB, and therefore now you would understand why I was very, very happy for all these three people coming here down here, because we have toiled for almost a year together. We have toiled for a year, and we tried to map the entire variant landscape of Maharashtra, and we have the total idea of what happened in Maharashtra during the pandemic. I'll show us a small bit of it as we move forward. I'll show you a small bit of it, of what stellar work can be done by sequencing when two big institutions like Government of Maharashtra and IGIB comes in. So I will show you that. So there was a memorandum of understanding between the two directors, the Director of Medical Education and Research, Dr. Lahane was the director that time, and Dr. Anurag Agrawal, who was the director of IGIB that time. And there are many people here sitting in this particular hall. More sir is there. Ingole sir? Yeah, Ingole sir is there. Ingole sir has a lot of work which was done during the pandemic. I will make a small reference to that, sir. Then I have Suvarna Joshi sitting here, who worked for Pune. Then anybody who was the district coordinator, can you raise your hand, please? Anybody was there? So no. So we have 3 or 4 important district. Yeah, you were there. Yeah, thank you. District coordinators who had worked. The job of the district coordinators was to have 100 genomes, 100 isolates, which had some significance. Anurag had very clearly told me that it's not just taking any sample and doing it, because Dr. Tambe mentioned it today in his talk, just at inauguration, that just because of convenience that you have a sample, sequence it. It's not like that. So what he had told us was, he made an elaborate plan. Vinod had sent it to me, Sridhar had sent to me, yeah, both of you. And what was written there was, 50% of the samples would be for epidemiological reasons. So the molecular epidemiology which we are talking of. And 50% of samples would be when they have some clinical significance. Maybe the symptomatology is different, maybe it's a breakthrough infection, maybe anything else, maybe he required more of oxygen, maybe he was admitted, a young person admitted in the hospital. So if you have anything like that, we had to select 50% of cases. So it was a very specialized job which has to be done, and it was very ably done by Ingole sir, More sir, Suvarna. All of them did that job very beautifully, and samples used to go to Sridhar sir. And Sridhar sir used to test them and give them in, I would say 1 week or so, maximum 1 week or so. And then the moment those reports came to us, we used to send it to Government of Maharashtra. Many a times Sanjay used to say, kya nikla? I used to say, no, kuch nahi nikla, wo government ko malum hai, tumko nahi, jarurat nahi tumko malum hone ka. So, collector satata tha, yeah. The collector used to ask them ki kya variant hai, and they used to ask me kya variant hai, main bolta tha director sahab ko puchne ka, humko nahi puchna. So that is how we did it. I'm just giving the numbers there. So if you see very carefully, the numbers were great to begin with, because at that time Delta was at the peak, and we had many patients of Delta that time. Then as we moved forward, the number of samples started trickling, because that Delta weight had gone up and it was ebbing. So the number of samples which we used to get was less. Now I'd like to show you something very interesting of what happened through the whole thing. Now, many a times what happens is we are always behind, we are always left far behind the virus. The virus moves so fast that we are just trying to catch hold of it. So we started tracing the virus, and this is how we started tracing it. So I don't think it would be very clear, but if you see the yellow thing is the Delta. And it was a Delta wave during which we started. If you see carefully there, you see other colors also. There are many variants, so we won't have a look at it. We'll just try to understand it was Delta and some other variants in different color. Something very remarkable happened here. Different colors just went off. The yellow remained, that is Delta, and a shade of gold, a shade of Delta, a shade of yellow is there, which signifies that it was the AY series which came up. Initially, I will go further and tell you how Vinod had made a particular point to me. I will show that also. But if you see carefully now, what is happening is the other colors are gone off and the only colors of delta remain and the subvariants of delta. The AY series is the subvariant of delta. Please try to understand why this happened. This happened because delta was finding it very difficult to grow. And therefore it had to add new mutations to itself so that it can, and that too with some immune escape, so that it can cause infection to other people. So the Pango people then gave different names to it like AY1, AY2, AY4, AY5 and so on. So it continued till August and then something new came up. Something new started coming in December 2021. This was a very important juncture in India. It was, I think, in South Africa that we found that there is one more variant which is coming up, Omicron. And the red color which you see, now I'm going to show you something very remarkable. So, dil tham ke baitho, I'm going to show you something very remarkable in the next slide. Now you see that these are all the districts, 36 districts of Maharashtra. And you see that most of them are having Delta, AY series, and in some districts you have Omicron there. Red thing. Now is the thing. Now you see what has happened. January, everything is gone. Delta thrown off, AY series thrown off, and it's all Omicron. How would you have got this particular insight unless and until there was molecular epidemiology? It was impossible. Otherwise, we would never have known what has happened in India, what has happened in Maharashtra. But then now we know exactly what happened in Maharashtra. And thanks to government, thanks to Anurag. Yeah. So if we trace Amravati now, we'll try to trace Amravati. What I have done is, I've started from the week-wise I have started. If you see, it was initially all yellow, it was all Delta, and then when you move towards the end, it's all Omicron. Buldhana, Yavatmal, Washim, gone. So I think this is what molecular epidemiology can do for us. This is what sequencing can do for us. And you would ask me a question of how was it this significant at all? Was it significant at all? Did you do it just for a research sake, just to know that, well, sequencing, we can do sequencing and therefore we did it? The answer is no. It answered very specific queries, very specific questions which were posed by the authorities. The first authority who posed me a question, the first question which was posed even before we started with sequencing, even before our MOU started functioning, the first question was posed by the then COVID advisor to the Chief Minister of Maharashtra. I won't name anybody now because the government has changed. So yeah, so that time the Chief Advisor for COVID to the Chief Minister made a direct phone call to me. He said, I am seeing a newspaper report in Samana. At that time, Samana, you know, Samana paper is the mouthpiece of the party which was ruling Maharashtra at that time. That there is a report from Aurangabad that children are getting affected in a large number. And at that time, just try to go back in time. Just try to go back in time. And you will remember that at that time, every expert was saying that now is the time for children to have the third wave. You're going to have children. Everybody was investing in NICUs, PICUs and everything. We had a lot of funding which was given. Many hospitals came up with this pediatric wards. They came up with NICUs, PICUs. And so what happened was, because Aurangabad was reporting RT-PCR test positive in children, it was thought that now a new variant has come in. And you are going to get the next wave, third wave, chalu ho gaya. So that was where this particular project helped. I made a direct call to Dr. Irvane. She's not here right now, but she was the district coordinator there. I made a call to her. I said, ये 50 जो निकाले, तुमने निकाले क्या? So she said, yeah, हमने निकाले. So I said, फिर उसका RN तुम्हारे पास होगा? तुमने तो टेस्ट किया तो RNA है तुम्हारे पास? So I said, RNA है हमारे पास. So I said, उसको उठा रहे हम. तो ठीक है बोले. So they took all the RNA with them And then I made a call to Sridhar. I said that, can we pick it up? He said, why not? The thing was starting then. Sridhar picked it up. We sent the dry ice and all the couriers and all, and that particular went to his lab. And a fantastic thing was done by IGIB. They came up with their own protocol. The protocol was at that time, the protocol was one which could identify the sequence in 48 hours. It was not possible then. It was going to it took 7 days at least for sequencing to be done. But they had a very fast protocol where they could do it in just 2 days. So I've mentioned it there that the samples were picked up on 16th, and in just 2 days we had the results. 18th we had the results, and we had made it a point. I was there. I had just one colleague working with me there, and that was because the confidentiality had to be met. And therefore, what happened was, the moment I got your report, the same night the report went to government, and the same report went to whom? It went to the chief advisor of the chief minister, telling him that there's no problem at all, no new variant has come in, it is just Delta which is causing the wave. So that was a very important epidemiological decision that time. We can look at it now, we can look at it as an afterthought, that well, nothing happened. You can say that, well, what happened? Nothing happened. But then at that particular juncture, we did not knew that nothing will happen, because we know what Omicron did. We know that what it did. And if it was a new variant, then we would have been ahead of the virus. So we were ahead of the virus. We told that it's Delta, and therefore there was no issue. Going further, one more question was posed to us by INSACOG. So initially we were not a part of INSACOG. And here also I would say thank you to him. People were not ready to take us in INSACOG. So there were some very big shots who wanted us in. And one of the big shots is sitting with us. So they wanted us in, that these people are working so hard. Just because they're a medical college and not a national institute, it doesn't mean that they shouldn't be in. At that time, it's an exclusive club. The INSACOG is an exclusive club. They don't let people come in. So we had that particular difficulty to go in, but they are very big shot and big people who said that no, these fellows have to come in. Maybe they are very what should we say, very naive and all, but still they have to come in. So we went in. And then what happened was, they then understood the importance of having a sequencing activity in a medical college. That's why we are taking this particular workshop and telling all of you that, well, just because you have medical college, it doesn't mean that you can't sequence. Justin is sitting here, Narendra is sitting here, yeah, and they would tell you that we have a sequencer which fits in your pocket and doesn't cost much. So why don't you start with sequencing? That is what they would tell us. I hope they would tell us. So this is how it is. So that's why we had this workshop telling you that you can sequence, and you do start sequencing. The importance was, because this particular sequencing activity was done by a medical college, it had the ability to see the clinical features of each and every patient which we had sequenced. And there it was important for the whole team which I had here. I have a bunch of very active students, very active students. I have 10 of them which I really love. The 10 of them are great. Then I have 10 more who have come in, and I'm starting loving them too, because they work hard. And then it was such a fast activity they did. They talked, they discussed with each and every patient telephonically. They asked for their symptoms, and then we came up with a study which INSACOG had told us to do, and that was whether AY.4 is dangerous than Delta or not. We answered, well, it's not dangerous than Delta. That was a very important decision which we gave to Government of India through INSACOG, that, well, it doesn't make a problem. And at that time, the INSACOG bulletin was edited by Dr. Anurag, and he added the sentence there that an early clinical study in Maharashtra. So that study in Maharashtra was BJ Medical College which did it. So that was how it happened. Yeah. Then this was that time it was a dangerous thing, because we had seen a particular mutation K417N, and this was specifically told to me on WhatsApp message by Vinod, that you have to look for this particular mutation, because at that time it was not called AY1, it was called delta with this particular mutation, and you will have to have a look at it. So when we found it for the first time, we again went for that accelerated sequencing mode, where we got the result in just 48 hours. So what we did was, we went to Ratnagiri. And here I would like to tell you how molecular epidemiology plays a role when the entire administration setup is with you. I made this particular presentation to the Secretary of Maharashtra Medical Education. I told him that there is some mutation. I've been told by the experts in the field that there is a mutation which we have to check in Delta. It may turn out to be a new variant, a more dangerous variant. So what did the Secretary do? The Secretary gave me the numbers of the collector of all the areas from where the sample was there. And he asked me to make a phone call to all the collectors, telling them that you will have to have all the contacts of the patient who had this particular variant in their throat. So this was a big administrative decision which was based directly on molecular epidemiology by the sequencing results. So what did they do? The collector, he himself also talked with all the collectors. The entire machinery of administration of that particular district just went down, and they got 50 samples for me. And the 50 samples were picked up by Sridhar. And in 2 days, we got the result. That, well, AY1 is not progressing as fast as it should, because there were only three number of isolates there. The rest was Delta. Again, nothing happened. So because nothing happened, we would say that, what was the use of it? No. At that particular juncture, we wanted to know whether AY.1 is more fitter and is going to take over the entire landscape. That is what we wanted to know. And this is the third one. This Parner Ahmednagar, I don't know whether somebody is from Ahmednagar here. And Ahmednagar was a very, the place where you had maximum number of cases of COVID at that particular time. We again, this was our third episode of going for accelerated sequencing. We went there. We wanted to know why it was so common. We thought that it was alpha or something coming in, some other variant coming in. But when we did it, we found that no, it was Delta. It was the Delta wave which was going in. Each time that particular Delta went to a place, it affected and increased the numbers. That is what we could understand later on. This was one more. Now this is, I think I had discussed it with you people, the lab, yeah. It was very long back that we could get N501Y mutation in Delta. The importance is that N501 mutation is specific for Omicron. So that we found in Delta, and therefore again we were afraid that something new has come up. We again went in for 50 samples, and again it was seen that, well, that was the only mutation which had occurred, and it did not spread at all. So in all, this is what we have done. We ourselves have sequenced 4,387 samples up till now. With IGIB, we have done 18,000 and more. And then we also made a consortium here in Pune. All the labs which I had mentioned earlier, ICMR NIV, DBT NCCS, CSIR NCL, and DST ICER, all labs in India made a consortium called as Pune COG. And this Pune COG has also sequenced more than 13,000 samples up till now. So in all, we are nearing maybe 32, 33,000 sequences by now. We are almost 1/3 to Justin's lab. Yeah. So these are the achievements which have been done by this particular college, and therefore this particular theme which we have, Kappa and Delta mutations in February from Amravati samples in February 2021. We pinpointed the entry of Omicron in India. In Maharashtra, in Mumbai, and in Pune, we pinpointed when Omicron entered India. Then lastly, the clinical studies on AY4, Omicron, BA.2.38, BA.2.74, 75 and 76, and the recent monster, BA.2.75. We were instrumental in identifying it, and we are predicting that it would replace all other variants all around the world. That is the prediction which we have. Thank you very much. Thank you.
What an excellent journey. Thank you, sir, for explaining and making us feel the thrill of chasing the new COVID variant. It was indeed an action-packed expedition. I request Dr. Mayuri to felicitate Dr. Karyakarte. I call upon Dr. Sheetal to conduct the next session.
Good afternoon all. Now I request Professor Justin to come on the dais. Introduce Professor Justin.
Yeah, I'm not leaving the stage, of course. So I'm very happy that Professor Justin O'Grady had come here and is going to deliver the first lecture, because he has made that kit. That's more important for me. So Justin gained his BSc, MSc and PhD in microbiology and infectious disease at National University of Ireland, Galway. He remained at this particular institute for his first postdoc, focusing on foodborne pathogens. This was followed by a 2-year stint in industry, that is Beckman Coulter, developing real-time PCR-based tests for infectious diseases, including tuberculosis. I would like to underline including tuberculosis. Professor O'Grady then returned to academia, taking a postdoc position at University College London on TB diagnostic, again underline TB diagnostic. In January 2013, he was appointed assistant professor in medical microbiology at University of East Anglia, Norwich, UK, was promoted to associate professor in August 2016, and then promoted to professor in January 2021. He then joined Oxford Nanopore Technology as Senior Director of Translational Applications in June 2021. His research continues to focus on rapid detection and characterization of infectious diseases to maximize community and patient benefit. Now this is what it was written. I want to tell something else also. First of all, he is not English, he is from Ireland. Yeah, that's the first and the foremost thing. He emphasized it 2 times to me. So yeah, everybody else has to know that. He's from Ireland. And more importantly, I asked him a specific question that do you like, I'm going forward. How come you went from academia to the commercial entity Nanopore? Because I was not able to understand why. Because there also he's doing the same research and he was doing the same research in academia. The answer was very pertinent and was the answer I think would strike a chord with everybody here. That is, he was making good research in the academic institutes, but what he said was it was not getting to the public. His research was not getting to the public, no use to the community, and he did not want that. He wanted to affect the lives of people. He wanted the community to be benefited, and that is the primary desire for his to go in Nanopore. Thank you, sir. So please, welcome.
Okay, first of all, I'd like to thank Dr. Rajesh Karyakarte for his kind introduction and for inviting me here, and all the organization committee for inviting me here today. It's been a strange few years, hasn't it? It's been a few years where people started to pay attention to microbiologists and virologists and epidemiologists more than they ever had before. And maybe for the first time in my life, my parents and my friends actually understood what it is that I do for a living. So that was quite interesting. But we've focused on SARS-CoV-2 for quite a while now. And it's important, and it will stay important for the next, foreseeable future, I would say, the rest of our lives probably. Just like flu, just like other important viral pathogens. But the question is, will we continue to spend as much effort in sequencing it and tracking it across the world? Probably not. That will wane over time. But what will we do with all this knowledge and expertise that we've developed in this field? of genomic epidemiology of pathogens as we move on. And that's, I think so many countries and so many organizations have built expertise in the area of sequencing that never had that ability before. And we need to take advantage of that as a scientific community. And that's what I'm trying to do, and that's why I moved into this company, Oxford Nanopore Technologies. And what I'm trying to do is develop new tests that will help us detect pathogens and characterize their genomes and diagnose them in patient samples really quickly so that we can improve what we do in the microbiology lab and make it even more relevant than it is today. So just to summarize what I'm going to speak about, I'm going to talk about TB, tuberculosis, and that's a very important disease in this country, as you all know. We have multiple methods and ideas of how we're going to target it, but we're going to look at a targeted drug resistance TB test I'll describe to you. I'll also describe an isolate sequencing approach that I think is very useful for epidemiology and further understanding of the disease. I'm also going to speak to you about nosocomial pneumonia, so hospital-acquired pneumonia, ventilator-associated pneumonia, things usually caused by bacteria or fungi. And then I'm going to talk to you a little bit about bloodstream infection, or sepsis as we all commonly call it. This talk will be quite scientific, quite in-depth. I hope you don't mind. I'm going to start talking about TB, drug resistance TB, and how we're developing an approach. So I'll just start off by talking about TB and drug-resistant TB epidemiology. So this is a test that we're developing that we hope will help diagnose TB and look at epidemiology and drug resistance all in one test. So I think this is an interesting slide that was developed by the Stop TB Partnership. And you can see that what it's showing is the difference between COVID and tuberculosis. Tuberculosis has been, was identified first in 1882 and COVID in 2019. You can see that there was one vaccine developed for TB back in 1921, and it really only works in children. And then there's been 18 by 2021 developed for COVID. There are 109 vaccine candidates for COVID. There are 14 for TB. There's a small amount of money spent on TB research every year compared to COVID. And if you look at the number of deaths per annum, they're very similar globally. So why don't we pay as much attention to a disease that's been around for many, many years as we did to COVID? Well, the answer to that is probably to do with the people that it affects. It tends not to affect the Western countries as much, the more higher income countries, and therefore there isn't as much money spent on it. So how big a disease it is, most of you here will know it's about 10 million cases a year and 2 million deaths, as I've just mentioned. And the COVID pandemic has had a big impact on how it's diagnosed and how it's been treated and looked after in communities globally. So the number of cases dropped from about, that were detected, dropped from about 7.1 million in 2019 to 5.8 million in 2020. And that's not because there are fewer cases. That's because there are less diagnostics going on, and that's because of the COVID-19 pandemic. Resources were driven towards COVID and away from TB. And if you look at the number of cases, incident cases per annum in the world, they're the top 3 countries on the right-hand side. And you can see that India tops the world in number of cases by a significant amount. So it's a very important disease in this country. Drug-resistant TB is a growing problem. They estimate now about a tenth of TB cases are drug-resistant. And drug-resistant TB is very difficult to treat. And the WHO are trying to improve on treatment all the time, but it is not an easy disease to work with. So when people have MDR-TB or XDR-TB, very drug-resistant TB, they often die. They're not diagnosed quickly enough, and this leads to very high mortality. There were approximately 500,000 cases of TB back in 2018, and they really only diagnosed 187,000 of those. So about less than a third. So why is that? Why aren't we diagnosing drug-resistant TB? Why are we letting people with drug-resistant TB spread that disease in the community? Well, it's because we don't have good diagnostics for it, and it takes far, far, far too long. And as you all know here, growing tuberculosis takes a long time. Doing drug susceptibility testing on grown tuberculosis takes even longer and is very expensive. So these are some of the tests that are used. You know, gold standard culture, as I mentioned, it's slow and it's dangerous to staff. You grow these bacteria and it can lead to laboratory-acquired infections. Line probe assays, like you see on the right-hand side, they're useful, but very old technology, 25, 30-year-old technology, only really can investigate a small number of mutations, SNPs, that confer drug resistance in tuberculosis. And you know, part of the WHO's plan on TB and eradication of TB is to implement rapid drug susceptibility testing methods in high incidence and low resource settings like India. So this is the first test that we've developed, and it's a drug-resistant TB test, and it's to be used directly from sputum. This is not a test to be used on cultured isolates. It's a test that could be performed directly on the sputum sample or decontaminated sputum sample that you would receive in the lab. How does it work? Well, we amplify 27 different parts of the TB genome using PCR, and then we sequence those PCR products on a MinION sequencer. Right? I'm not sure if you're all aware what nanopore sequencers look like, but you know, a nanopore MinION is about the size of a chocolate bar, and it's capable of producing a similar amount of data as an Illumina machine or a PacBio machine. And that makes it easy to move around. It's inexpensive. The machine itself costs about $1,000, and you get free flow cells with that. So it's something that is accessible for laboratories in low resource settings. So what we do is we amplify up these parts of the genome, and these are all the genes on the right-hand side of that table, and on the left are the drugs that we're testing for resistance to. And we test for 16 anti-TB drugs, and we test for drugs included in the new WHO regimen for treating drug-resistant TB, which is called BPAL. BPAL is bedaquiline, protomanid, and linezolid. So we test for those 3 drugs as well, and they're new. We can look for over 1,200 SNPs, over 1,200 drug resistance associated mutations. And that can all be done in this one test. And we're able to test for first line, second line resistance as mentioned. So this describes how the test works. So you start off, on the left-hand side, you bead the sample, so you physically or mechanically disrupt the sample, and then you extract the DNA. We tend to use an automated machine, but I think you can use a manual column-based purification of the DNA after the bead beating if you wish. That whole process takes about 45 minutes between those 2 steps. Then we do multiplex PCR. Multiplex PCR there's 27 primers in one reaction, and it takes 90 minutes, an hour and a half to do that PCR. And then we barcode the sample and get it ready for sequencing. That takes about a half an hour. And then we do the sequencing itself for just 2 hours. And so the whole process takes less than 5 hours. And we have an automated analysis pipeline that will then analyze the data and tell you whether the sample is resistant or not. So I won't go into detail here, but there's an informatics pipeline. You don't need an internet connection to run it. You don't need to upload lots of data to the cloud. We've avoided that because of the types of settings we want to use it in. So it will give you it will genotype known SNPs. The SNPs are on this list of SNPs on the right-hand side here that the WHO have produced. And they group these SNPs into different importance based on how regularly they're seen in the clinic. So we find all those SNPs, and we can diagnose drug resistance based on the detection of those SNPs. We also look at spoligotyping. For those of you interested in TB genomic epidemiology, you'll be very aware of spoligotyping. So we have a pair of primers that does spoligotyping in there, and we can give you a spoligotype to tell you what this particular TB lineage is. And then we also can tell you if it's a non-tuberculous mycobacteria, if it's something that isn't in the Mycobacterium tuberculosis complex, that it's one of the other mycobacteria, which can sometimes cause disease as well. So then there's a run report and a sample report. The sample report would be more for the clinician, and the run report would be for the scientist or the lab people. So I'll show you those two reports. So the one on the left here is the overall summary report, and that tells you about all the samples on the run. We usually do 24 samples at a time, but you can really do anywhere from 1 to 96. So it's up to you. So this sample report on the left shows, you know, that the positive is sampled, that all the controls have worked, and then it shows in a kind of summary table what resistances are present in each of the samples. The picture in the middle shows what the report for the clinician would look like, and that captures some data on who ran the report, when it was ran, and then it shows whether the sample is positive or negative, what resistance mutations it has, and what drugs it's resistant to. And then finally is the spoligotyping report on the right-hand side, and that shows you the lineage. So this particular test is under evaluation by the WHO and FIND, and there's a thing called a Seek and Treat study, where FIND have asked, and the WHO have asked the global community to develop a test like this. And so we're in this evaluation with FIND and the WHO, and we're at the second stage where the arrow is there, and it's just, we're in a clinical trial at the moment. The first stage was to test 392 highly characterized sputum samples. We did that. The test worked very well. It worked within the parameters that they wanted. It was 98% sensitive and specific, at a very good limit of detection of below 100 TB cells, and we could detect mixed resistance 10 to 10%. So we moved into the second stage of the trial, where you'll see in Mumbai we've tested 379 of 379 samples that they were meant to test, and that's Dr. Camila Rodriguez that's doing that work. Then in Tbilisi in Georgia, we've tested 216 out of 216 samples. In Johannesburg, we've tested fewer, about 66 out of the 157 required. And when they're finished, the WHO will analyze the data and tell us if the test is good enough to move to the next phase. We expect that it will be, and that will start in January 2023. So that's it for the first test that we've developed. That's our drug-resistant TB test that's to be used directly from sputum. So now I just wanted to mention something else we can do. So if you're interested, if you grow tuberculosis in your laboratories, and you're interested in sequencing the whole genome of that isolate that you have, either in a midget culture or perhaps you grow them on LJ slopes, and you have this cultured isolate and you want to sequence it to find out its resistance or to look at its epidemiology, then we can offer whole genome sequencing approach. Here you would take liquid or solid media, and you would use this rapid barcoding kit that we have, this library preparation method. So once the DNA is extracted from the sample, using whatever method you like, then you would use this rapid method to prepare a library and then sequence the organism. You can fit up to 48 TB samples on a single flow cell, and a flow cell will cost you, somewhere around $500. So you can do an isolate, a TB isolate, for $10 using this approach. Now, we haven't got our protocol ready for this yet, but it will be ready in the next month or so, and that will be published online, and we can share that with you. So I just wanted to show you this particular paper, and it's very hard to see on the screen here. But what's important is this publication comes from the Cryptic Consortium, which is a group of scientists based in Oxford and all around the world. And what it says here is basically that nanopore sequencing for the detection of SNPs in TB isolates performs as well as Illumina sequencing for the detection of TB SNPs in TB isolates. So that's important. Some people ask us a lot, is nanopore as accurate as it needs to be to pick up SNPs? The answer is yes. Is it as good as Illumina? The answer is yes. And that's not our research. That research has come from independent people. So that's it for TB. So now I want to move on to a second test that I've been developing over quite a period of time since before I joined Oxford Nanopore, and I was an academic at the time. And this is all about pneumonia and hospital-acquired pneumonia, ventilator-associated pneumonia, community-acquired pneumonia as well. Any respiratory infection, lower respiratory infection, where sputum or bronchoalveolar lavage is used for diagnosis, or endotracheal tube aspirates. So these types of infections cause many deaths per annum in the world. And of course, we know that we use culture to diagnose them. There are many steps in culture, as you're all aware, and it takes time. And so, in the meantime, obviously, every patient is treated with some form of broad-spectrum antibiotics, and that's really not ideal most of the time, and often we get very poor patient outcomes, and it's poor antimicrobial stewardship as well. So, we're trying to develop methods, and this type of approach that I'm going to speak about today is called clinical metagenomics, where we apply metagenomic sequencing to clinical samples. And it's agnostic. So what does that mean? It means that it is, pathogen. It doesn't matter what pathogen is in there. Is it a fungus, a bacteria, a virus? You don't have to know anything in advance to know that this test should work. We can use it to perform diagnostics, but we can also use it to look at genomic epidemiology at the same time. We can use it to do infection control in hospitals, look at transmission studies. If you find two patients with similar infections and you wonder, has there been a hospital transmission event? Well, you can use these approaches to check for that. So what we want to do is, replace a lot of what's being currently done with culture with a single test, this clinical metagenomic test. So, sequencing has been around for a number of years, and the question is, why hasn't everyone started doing this? Well, one of the biggest challenges with applying sequencing to any clinical sample directly without doing PCR or any targeting is that most of the sample is human DNA. So if you think of it, in a blood sample, for example, there are about 10 to the 6 leukocytes, and there might be 5 bacteria in a ml of blood. And so you need to be able to take away all that human DNA and that human cells to try and balance up what you can detect in the sample. So the solution to this is really kind of host DNA depletion, and that's removing human DNA from clinical samples. So we've developed, a way to make this needle in the haystack bigger. So we just want to be able to try to find the bacteria in this mix of human soup. So we've developed these methods that can remove, 99.99, so 10 to the 4-fold reduction in human DNA from clinical samples. That's respiratory samples. We can get about 10 to the 6-fold reduction in blood. Sputum is a little bit more inhibitory than blood, so the methods work better in blood than they do in respiratory samples. So we've developed this approach, and this is what it looks like on the right-hand side. You do this human depletion bit first, and then you do an extraction, DNA extraction, like you do for any test. Then you do a cleanup step where you just wash the DNA and just make sure it's very clean. And then we do a library prep. So we move into a thing called tagmentation, which is part of the library preparation for sequencing. And then we amplify all the DNA. It's not targeted in any way. It just amplifies all the DNA in the sample. So it's what we call whole genome amplification. And this allows the test to be more sensitive. And then we clean it up again, and then we put it onto the sequencer and analyze it. And we can do that whole process in about 4 hours. That's from sputum to result. And so we can do it on sputum, bronchoalveolar lavage, endotracheal tube aspirates, any lower respiratory tract samples that you get. The method can give you whole pathogen genomes at the same time as diagnosing infection, and it is very sensitive and specific compared to culture. So we published this approach back in 2019, just before the pandemic, in Nature Biotechnology, and it made it to the front page of Nature Biotechnology, which I was very proud of. And that's the paper there if you're interested in reading it. And the paper with the blue color below it is on how we applied the test during the pandemic in the ICU in one of the best hospitals in London, which is Guy's and St. Thomas's Hospital in London. So we did a study there with Professor Jonathan Edgeworth, and we applied this test that I've described in these ICUs during the pandemic, just to see if anyone had secondary bacterial infections that had COVID. At the time, we thought that that might be quite important. It turns out secondary infections in COVID are not that important. So, you know, we did a pilot study of this method as well as that COVID study, and this pilot study was on ECMO patients. I'm not sure if you have ECMO patients in the country here, but you know, in specialist hospitals in the UK, there are ECMO wards where these patients have their lungs have stopped functioning, so they remove their blood and oxygenate it outside the body. And so they're very ill patients. And so we did a study on those type of patients, some other patients that were in the ICU who were very unwell. We collected 128 samples over a 15-week period, and we performed metagenomics on these patients. The breakdown is there. 36% were ECMO, 38% COVID, and 66% male, the median age of 40. Clinical metagenomics had very high sensitivity and specificity, which was good for detecting pathogens. But I think what's much more important here is not just diagnosis of the pathogen, it's what you do with the results. So the most impactful thing that we found with using this test is that if you look on the second from the end column, you'll see what the decision was from the attending physician to do with the antibiotics, okay? So sometimes we found no significant pathogen, and in that context, the decision was by the clinician to stop antibiotics. So that's a very useful thing to do. A lot of people don't stop antibiotics because culture takes too long to provide the results in time for a decision to be made on what to do with treatment. So they just keep treating the patients even though they don't need antibiotics. So when you find a negative result in 4 hours, then you can say to the doctors, we recommend that you stop treatment. So that's impactful. That's about half of the patients that happened with. If you look at the second row here, you'll see that they de-escalated for susceptible bacteria. So we were able to tell the doctors quickly if they had a bacteria that was susceptible, they could de-escalate their standard therapy. In the UK, if you get a hospital-acquired pneumonia or suspected of one, you will receive piperacillin tazobactam. That's the standard of care. And so when I say de-escalate or escalate here, I'm talking about changing antibiotic from that standard of care. So we de-escalated in about 18% when we knew there was only a susceptible bacteria present. Then we found some anaerobes. They were interesting. And sometimes we targeted some therapy for the anaerobes, and sometimes we de-escalated based on those results, depending on the organisms that were found. And that was in about 10% of cases. Then we found like resistant bacteria. So these were bacteria like ESBL, Klebsiella pneumonia, Enterobacter, Morganella, these kind of things. And we escalated in those patients, usually to meropenem. And then we found some very interesting results using clinical metagenomics, and this is where it really shines. And we found Legionella pneumophila. So, and nobody suspected it. It wasn't the typical lineage. It wouldn't have been tested positive by PCR. No one would have tested it by PCR anyway. And that led to an infection control intervention from Public Health England, and they had to change the water system in the hospital. Another organism, T. whipleyi, that's an organism that won't grow in culture. So a patient had that, we detected it using metagenomics, and that patient was treated for that and became well. And then other things like M. tuberculosis, which wasn't suspected and we found, and the patient was tested and treated. So this approach has a lot of strengths. I think the weakness that this approach does have, though, is in a complex environment like the lung, where there are multiple organisms and not just pathogens, there are commensals, we can't always tell whether the resistances that we detect are associated with the pathogen or with the commensals. No molecular method can do that at the moment. So that is a weakness, and that's why I think we need to have culture alongside this particular test to make sure that we can take the isolates and make sure that the results we're detecting using this approach are accurate, particularly AMR results. So this same data was able to be used to identify 2 outbreaks in the hospital that we weren't aware of. So there was higher than anticipated prevalence of Klebsiella and C. striatum in this particular set of data. And so we went and looked at those whole genomes, and we did SNP analysis between those genomes, and we were able to figure out that these were outbreaks, that these were hospital-acquired infections caused by hospital transmission. There were in-hospital outbreaks. One was an MDR pneumonia ST307, and then there was a C. striatum outbreak involving 14 patients in 3 separate ICUs. And, you know, I won't go into this, but this data is a mix of traditional epidemiology with genomic epidemiology to look at the movement of patients across ICU wards. And you can see that, you know, what happened was patients in red wards moved around and spread these particular infections to each other, and that's what happened. So that's all I'm going to talk to you about on clinical metagenomics and pneumonia. And the last thing I'm going to talk to you about today is bloodstream infection or sepsis, and I'll keep it brief. So you'll all know about sepsis. It's life-threatening infection, tends to leak from a source in the body, the lung, the gut, wherever, the urinary tract often. Bacteria get into the blood and cause the body to shut down effectively, and it causes death. So mortality rates are very high. It's estimated, if you look on the bottom right here, you know, there's 40 million, almost 50 million cases globally and 11 million deaths, one of the biggest killers in the world. Oddly not mentioned on WHO lists because it's not considered one infection. You know, it's a syndrome, but it kills many, many people, many more people than most diseases. And so, you know, it's obviously very important. What's the problem? Well, if you don't receive the right antibiotic early in the infection, the mortality rate is very high. So rapid diagnostics are very important. What we're trying to do here is to create a very simple and fast method to diagnose sepsis or bloodstream infection using sequencing. So what we do is we start off with a centrifugation step. We split the blood into plasma and buffy coat and red blood cells. And then we extract nucleic acid from the sample, from the plasma sample. We spin down the sample slowly so the bacteria stay in the plasma. And then we perform a PCR, and it's a targeted PCR. This is another targeted approach. So it uses 16S and ITS to look for bacteria and fungi. And then we do a wash of the sample, we get, and then we do a library prep, and then again sequencing, and we sequence for about 20 minutes. So this whole process takes about 3 hours, directly from blood. And it, you know, it looks a little bit like this. You take the sample, we take 5 mils of blood, we spin it down, we take off the plasma, we get bacteria and fungi, and then we bead the sample and extract the DNA using the Promega Maxwell, but as I say, you can use a manual method to clean up the DNA if you wish. So we spike blood. We're currently at the stage where we're spiking blood. And so we spike the blood with very, very low levels of bacteria, and we see if we can detect those bacteria. So in this case, we have 5 mils of blood. We've spiked it with 1 to 2 bacterial cells per mil. It's very hard to accurately get 1 or 2 bacteria into a sample, but that's what we try to do. And then we bead it, do the process, and then we sequence and analyze. And if you look at the table on the bottom right, you'll see a sample that we've spiked with Staph aureus. You can see that we get lots of reads. We've got a control sample and a Staph aureus sample. The one on the bottom is the Staph aureus sample. The one in the middle is the control sample. You will get reads in the negative control. You will always get reads in your negative control when you do sequencing type approaches. What's very important is that those reads are not pathogen reads. So if there are any pathogen reads in a negative control, you've got to discard the test. It's no good. So we got reads, but like the reads come from this weird and wonderful Snod Gracella something. So that's fine. That's a kit contaminant. That's coming from our reagents. And we're working hard to get rid of all that contamination. But you'll see down on the bottom, we've got 31,000 reads from Staph aureus, and that's about 48% of the total. 31,000 reads in total. 15,000 of those are Staph aureus. That's about 50% of the reads. And the rest of those reads are just, again, kit contamination. But that's sufficient. That's a lot of reads, and that's sufficient for us to easily identify the Staphylococcus aureus and easily to identify the difference between a positive and a negative sample. And this is with very, very low levels of bacteria in blood. So we think this will be a very good test for the diagnosis of sepsis and will be very easy and rapid. And that's really it. So I'd like to say thanks for listening, and I hope I didn't go too in depth for you.
Listen to Professor Justin, and we got to know about various sequencing approaches for detection and characterization of various infections. Now I call upon Dr. Gitanjali to felicitate Professor Justin.